morning. Today I will show how to guarantee that messages from a message bus are committed into a LiveView table before removing them from the durable queue. This ensures that if there is a communication interruption, that no messages are lost. One important reason to use a message bus for message delivery into a LiveView table is to preserve the message until it has been fully processed and stored in the LiveView table. There's a trivial and wrong way to send messages from a message bus into a LiveView table that breaks that guarantee. LiveView tables provide a protocol and API which preserves this guarantee efficiently. For illustration, I am using the TIBCO EMS adapters in my table publisher, but this applies to any publisher that needs to guarantee delivery. First, let me show you the wrong way. The reason this is incorrect is that it does not guarantee that the tuple made it into the table. The reason the table row update might not have occurred is that there is an input queue to the table, and the queue for various reasons may be backlogged, but the acknowledge happens immediately after the LV publisher takes the tuple. The reasons that the queue to publish a tuple may be backlogged are: the message rate is briefly or frequently higher than the table was provisioned for, an unexpectedly demanding query was submitted by a LiveView client, for example, an unindexed query, a complex aggregation, or a large result set that involves frequently updated rows. Machine or VM resources are temporarily restricted due to external demands for shared resources. The correct way is to use the LiveView Embedded Publisher API streams, query the last good record out, and the last good record in, to verify what rows have been committed to the LiveView table. This is described in the stream-based product documentation, LiveView Development Guide, LiveView Data Recovery, Publisher Recovery Protocol. The Query the Last Good Record Out and the Last Good Record In streams are part of the Recovery API, but should be used during normal processing to guarantee specific table updates have occurred. Let's look at the EMS recovery sample for how these might be used. There are 3 samples, one for TIBCO EMS, one for TIBCO FTL, and one for Apache Kafka. The Apache Kafka API is the easiest to implement for LiveView recovery. There's a little mismatch between what LiveView wants and what EMS wants to deliver, so recovery is a little bit more complex. This is the EMS recovery sample. As shown in the sample, and when you create a LiveView publisher using the wizard by right-clicking on a table in the Streambase Studio LiveView Project Viewer, you get an interface with all the recovery API streams. Let's look at the key parts of this example which relate to guaranteed delivery and acknowledgement. Note that when using an embedded publisher, we do not use the LiveView Publish adapter, but use the Data Layer Direct Communication API stream published to orders out. The table name in this sample is orders. This is an in-memory connection which avoids using the LiveView protocol, LV:// over the network, so it is as fast as possible with the least amount of work. Each tuple identifies the publisher with the value of the publisher ID field and a message sequence number we calculate identified as the publisher sequence number, publisher SN field. These are written to the table along with the data. It is the publisher sequence number value which is returned from the last good record in stream in the field lowest published sequence number, which tells us the highest sequence number for which all sequence numbers prior and itself are committed to the table. We receive the last good record in report only when asked, which is why we have the metronome pulling an input into the query the last good record out stream. So how do we know what messages to acknowledge when we have the lowest published sequence number value? With each message received from EMS, we write the calculated publisher sequence number value and the message ACK ID value from EMS into a local query table. We then look up the associated message ACK IDs whenever we receive a new lowest published sequence number value. We do not use a query read operator, but instead a query delete operator which is set to emit only the old table field value of message ACK ID. This accomplishes in one step reading all the message ACK IDs we need to acknowledge and removing them from the table. Let's simplify this example to the pieces needed for acknowledgement only. The guaranteed publisher consists of the EMS consumer adapter, a sequence operator adding the publisher sequence number value, a publisher ID value, a query table storing publisher sequence number along with message ACK ID, and output to the table published to table name out stream. In the acknowledgement path, we see the last good record in stream providing lowest published sequence number values at intervals, reading from the query table to drive message ACK ID values into the EMS acknowledge output adapter. And finally, a metronome requesting a report from the query the last good record out stream for this publisher ID. This pattern provides guaranteed publishing to a LiveView table from a message bus. Thank you for watching this presentation. Please leave any suggestions or comments here or visit our community site. And of course, don't forget to subscribe to our channel.